Hello, my name is Wyatt Rabita, and this is my Physics 2212 Lab 2 presentation. The purpose of this lab is to more accurately define the electric force when multiple charges on the tape provide towards the net total electric field, instead of treating the tape like a singular point charge. The materials for this lab are GlowScript and the results from Lab 1. And a brief preview of the result is on the right, with Q equaling 2.9244 times 10 to the negative 8 coulombs. Before we get into the details of the lab, we have to go over some fundamental physics principles, such as Coulomb's law and the gravitational force on Earth. Coulomb's law shows the force between two objects. K is Coulomb's constant, 9 times 10 to the ninth. Q1 and Q2 are the charges of the objects, and R is the distance between the two. The gravitational force on Earth is a variant on Newton's second law, F equals ma, where A is equal to g, which is equal to 9.8 meters per second squared. Here are the initial conditions of the lab. These were also in Lab 1, where the tape's mass was 0.002 kilograms, and the leftover charge from Lab 1 was 1.447 times 10 to the negative 8th coulombs. And the distance between the two tapes was 0.031 meters. Here is the model of the tapes. The system is tape B and the surroundings are everything else, and the forces acting on tape B include the electric force from tape A and gravity. Creating a model in GlowScript. Before calculating anything, we can use functions to help make our lives easier, especially when creating and visualizing the model. The E-field function determines E-field when given a charged particle and an observation location. The line charge function defines the line of charges given the position, axis, mass, charge, number of charges, and color. Defining the lines of charges. Using the line charge function, we can create two lines of charges to represent the tapes. Changing the n value also affects how many charges are in each line. Calculating the electric fields. Using nested for loops, we can calculate the electric fields and forces at each n location. The E-field function produces an electric field through calculation, which gets used in calculating the E-force. Model results. When Q is equal to 1.447 times 10 to the negative 8th coulombs, the excess charge found in Lab 1 on the tapes, the combined electric force has a magnitude of 4.80354 times 10 to the negative 4th. The magnitude of the force of gravity is equal to 1.962 times 10 to the negative 3 newtons, which suggests the net force is not zero, meaning the model that assumed the tapes were like point charges was inaccurate. To more accurately calculate the excess charge left on the tape to produce zero net force, we can use the formula for the electric field of a rod, which is symbolized by this equation. After setting the electric force equal to the force of gravity, Q is equal to 2.9244 times 10 to the negative 8th coulombs. To get this result, we had to make some assumptions. The first assumption is that air resistance was ignored for tape B when moving. The second one was that each U-tape had the same amount of charge, and the third one was that the charges on the tapes were distributed evenly. Potential sources for error from Lab 1 included the distance between the tapes being hard to measure, so the true distance between them could be different. And the tapes may have less charge due to touching and handling them, meaning the excess charge may be less than calculated. Here are some extra questions. What if you had modeled each of your tapes as a single point charge, like in the previous lab? Modeling the tapes like point charges, like we did in Lab 1, would have led to the excess charge being equal to 1.447 times 10 to the negative 8th coulombs compared to the result that we got from Lab 2. Why do these estimates differ, and which is more likely to be closer to the real value? These values differ because when we consider more charges exist, the actual electric field becomes more like the electric field of a rod. The closer value to the actual excess charge on the tape is the one when we consider more charges. The more charges we add, the closer we get to the actual excess charge left. That's it for my Physics 2211 Lab 2. Thank you for your time.